Hello class, welcome to another section of our intensive calculus course. We still work on functions. We did functions the first part in our last class. In this class, we're going to continue the various types of functions we have, as well as their various domains and ranges, and some important facts you are supposed to know about them. If this is your first time visiting this channel, don't forget to subscribe, turn on the notification button, and keep on track with the course you're doing. Kindly watch this video to the end so that you understand every part of the video, and don't forget to like the video as well. In this class, we're going to consider power functions, polynomial functions, rational functions, as well as algebraic functions. When we say power functions, let me take the power function first. When we say power functions, as the name denotes, we are dealing with an exponent. So, generally, power functions are represented in the form ax to the power p, where p is the exponent and a is the coefficient. Now, take note, a can never be equal to 0. Yes. If a tends 0, our function becomes a constant function. So for every power function, it's represented in the form a multiplied by x to the exponent p, where a is not equal to 0. And the power functions, we have different types under it. We have the monomial, the reciprocal, and the radical. These types arises from the nature of the exponent. P can be equal to positive or negative or a rational function. So if P tends to be a positive number, then you can have an expression like 2x to the power 2. Yes, this is a power function with P being 2 and a positive number. So we term this as a monomial. A monomial. So a monomial is a power function which has P to be positive. Let's go to reciprocal. The power function becomes a reciprocal function when P is negative. So I can have 2 to the power x negative 2. This is a power function, but we have P to be negative 2, hence this is reciprocal. This can be rewritten as 2 over x squared, and this is what we term as reciprocal functions. Then I come to the last part of power function, which we call the radical function. For radical function, that is when P is a rational function. Yes, so I'm going to have something like 2 multiplying x to the power 1 out of 2. This is a radical function because the P is a fraction. This can be rewritten as 2 then the square root of x. So when you say power functions, this is all about power functions, the various types you're supposed to know, and when to classify a function as a power function. I have examples here for us to consider. I have 3 examples, 1, 2, and 3. So let's consider those examples and see. Taking the first one, x to the power 2n. Yes. If I have x to the power 2n, what is the domain and what is the range? Let's ask ourselves. We can realize that this function can accept any number and it will still be defined. Yes. So therefore our domain is simply equal to all real numbers. What about the range? The range is going to be positive numbers only, irrespective of the number you put here, because it's 2 times n. We are going to be getting positive numbers. So meaning that our range is simply equal to all positive real numbers, and the correct notation is R subscript plus, yes, all positive real numbers. Take note, s to the power 2n will never give us a negative number. Let's take the second example. This one was the monomial. Let's take a reciprocal, x to the power negative 2n. When you take x to the power negative 2n, this is a reciprocal power function. Let me make it that way. So what will be the domain? What will be the range? Now, we can see that it can accept every real number. So our domain is simply all real numbers. What about the range? What will be the output of this function? So let's see. This is the same as 1 out of x to the power 2n. So if you put any number here, we can never get a negative number. Everything will be positive. So our range will also be r plus. As simple like that. Now we move to the third part, which is a radical function. So x 2n square root x like this. Yes. If I have this is a radical function which happens to be a power function with the power 1 out of 2n. So to find the domain of this function, I write my domain down. Then I ask myself, what are the inputs of this function? What can I input into this function? Yes. What are the things when I input here, I'm going to get a valid solution? Under the square root sign, for a valid solution, I need to put, or I need to restrict my inputs. So terms which are less than 0 are not supposed to come here. If I have terms here and they are less than 0, they are not supposed to come here. And sorry, for this question, the reciprocal, for our domain, I think 0 cannot be part of our domain because it will be a rational function. When 0 comes, it will be undefined. So this is how you write it. You write r, then you bring minus, then you bring a curly bracket, you put 0 inside. So this is how we do it. You put r minus 0, so meaning it's all sets of real numbers minus 0. Thanks for your compromise. So 2 to the power n square root of x. How are you going to get the domain of this? So this function, when I put 0, yes, it's accepted. Let me write it for so you can get x1 to the power n, yes. So here, when I put any number here, including negative, here is the same as, if I'm to rewrite this, I'll get x to the power 1 out of n all squared. Is all squared? Yes, I'm going to get, all the square root again. So I want to draw a scenario here. So let's say the domain, you're going to have a set of all real numbers, then you put the exceptions in there, and the exceptions are going to be there. So what you're going to do is, for a better representation, you just put r plus, yes, r plus. That is, you have excluded all the negative real numbers. So our domain here is what? R plus. Now what will be the range? The range is simply going to be, what will be the range? The range is going to be the output. So here we can't get a negative output, so it's also r plus. This ends the power functions. Let's move to polynomial functions. When we say polynomial functions, we've been doing that in elective mathematics way back in high school. So polynomial function is simply the sum of monomials. So it's generally represented by a0 plus a subscript 1 x plus a subscript 2 x squared plus, then it extends to infinity to the general notation an x to the power n. So a polynomial, as you say poly means a group or more than 2. So polynomial is the sum of different monomial, and we said monomial is a power function in which the p is positive. Take note, we can see that ax squared is a power function. So the types of functions, they are transitional, take note. So when I consider a polynomial function, every polynomial function has has a domain which is all real numbers. So the domain is, this is the domain which is all real numbers. But let's take note of some features of polynomials. When I take this polynomial general notation, a here can never be 0. A is a non-zero real number, and the power n can't be negative. Take note for polynomials. In polynomial, the powers are never negative. Then, when you come here, polynomial, I'm talking about the range and the domain of polynomial. So I have a typical example of polynomial here, which I wrote for consideration. So this, I have 1 out of 2 plus x squared as my function f of x. I'm to find the domain and the range. So to find the domain, you can see that this expression can never take any input. That will give us undefined. Hence, the domain is simply all real numbers. What about the range? What will be the output of this function? To consider the range, you can see that if I take x to be 0, that will be the minimum value of x. The value of x that will take this away. Because if I put a negative number, I'll still get positive. So the minimum value of x is going to be 0, and the output will be half. So meaning our range will start from 1 out of 2, then inclusive, then what will be the maximum? The maximum can be any huge number, so we put positive infinity open. So this gives us the range and the domain of polynomial. So when you are given a polynomial function, these are the stuff you have to consider. I'll be posting a lot of tutorial videos on this. This is a lecture class, so kindly follow this course to the end. The third part is rational functions. When you talk about rational function is the quotient of two polynomial functions. If you have any two polynomial functions and take the quotient, you're going to get a rational function. So this is so simple since we know polynomials already. I just take an example here for us to consider a rational function. So when I take a rational function, I'm going to have this here, which is x cubed minus 2x over x squared minus 1. So this is a rational function which is a quotient of two polynomials. So how do I find my domain? How do I find my range? Now, domain, as I explained in our first lecture, I said domain is all the possible inputs that make the function defined. So in this, what are some of the terms that can make this undefined? In rational function, if your denominator happens to be 0, you are going to get undefined. Hence, I'm going to eliminate any number that will make this undefined. So my domain is simply all real numbers minus, then we go to solve for the values. So if I have x squared minus 1, it shouldn't be equal to 0. So therefore, I'm going to have x is equal to plus or minus 1. S not equal to plus or minus 1. So x minus, open brackets, 1, then negative 1. So this is simply my domain. You take the range minus all the terms that will make it undefined. Let's go to the range. What will be the output? So we can see that after we have eliminated this, the rest is going to be a set of all real numbers. So the range will have no alterations. Finally, let's go to the last function for this class, algebraic functions. Algebraic. When you hear algebraic, that is algebra. Algebra deals with applying operations on a set of values, a set of variables, a set of parameters. So here it is applying operations on a set of functions, and the functions should be polynomial functions. we can also have the square root of functions. I mean, when you find a sum product quotient of functions, then you are going into algebraic function. So let's see a typical example I have here for my algebraic function. A typical example I have here is square root of x minus 1 over x minus 1. Yes, this is a power function, this is a rational function. So when I do this operation, then we call it an algebraic function. So take note of algebraic functions. As usual, we consider the domain, then we consider the range. So what will be the domain of this function? So considering the domain, a set of numbers that will make this defined. When I consider this part of my function, numbers which are negative will make this undefined. And when I consider the right part, 1 is going to make this undefined. 1 is going to make this undefined. So therefore, I'll have a set of all real numbers. Let me make it a set of all positive real numbers, because to eliminate the negative numbers that will come here, minus, I have here 1. If I put 1 here, he'll be undefined, so minus 1, like this. So this is the domain. This is the set of numbers that will make this defined. Set of all positive real numbers, then minus 1. What about my range? What will be the resulting output? Once I take every negative out and 1 out, I'll be left with positive output. So my range is simply R. This is about the end of this class. Thanks viewers. Hope expecting you in the next class. Don't forget to like the video and also share to friends to enjoy the calculus course.